Hi, this video is the first of a new 3-part series about the OptiCore add-on for Blender. Now, I originally created this add-on a few years ago and now just released a big functionality update so that it's proper time to make a new introduction video as well as some new tutorial videos. So first of all, for those of you who've never worked with the add-on before and just found it for the first time, OptiCore is an add-on intended to help you accurately model optical elements in Blender. So for example, it could be an achromatic doublet lens like this, or with a new functionality upgrade, also more complex lenses comprised of multiple elements. For example, here a DSLR zoom lens. And in this first video that you are watching right now, I will briefly run through the functions that this add-on provides, just show them to you in Blender so that you know what exists and where to find it. And then in part 2, I will be giving a more deep dive into complex optical systems, what you can do with them, have a look at a few different types of optical systems and where you can find templates for those. And then in part 3 of the series, I will show how to set up a lens system for rendering with the Cycles engine. To download and install the OptiCore add-on, you have to go to GitHub. So you find the OptiCore add-on under my username codefhd. So github.com/codefhd/OptiCore is where you will find the source code. And there is no official release version. This is basically a rolling release add-on. So just go here on the green code button, click on it, download zip. You will get a zip file of the entire code. And then in Blender, in the edit menu, preferences, add-on section, in the top right corner, you can select install from disk. There you simply select the zip file that you downloaded, and that will install the add-on. Okay, so let's take a look at the available features in OptiCore. As I said before, in this video I will only give a very brief demonstration of each parameter and show very briefly what it does without further detailed explanation what the optical significance is. That will be left to tutorial videos number 2 and 3, otherwise it gets too long for this video. So you can find the content in the Add Mesh menu, where you have 2 submenus, one for optics and one for Optomechanics. Optomechanics is unchanged from the previous version. So the main feature is the lens, which by default will look like this. And you got the operator menu here at the bottom, which by default opens up with a most important settings page. So quick word for those of you who've used the update add-on in the past, that now because the number of parameters has grown, I've separated this into several views, like most important selection or more elaborate optical design parameters, for example. So let's start with the most important category. To make it more obvious what I'm doing, we can generate a cross-section model and display the whole thing in edit mode, which makes the surfaces and the geometry more visible. You can either create a singlet lens, so one lens with 2 surfaces, a doublet lens, and a triplet lens. It's very uncommon in reality to have more than a triplet lens, so I'm only supporting this at the moment because adding more surfaces would also blow up the source code a bit more. Okay, and besides the geometry or the number of surfaces, you can also use an internal so-called sequential ray tracing feature, which will trace a few rays through the surfaces and show you how the lens focuses the light. At the top 2 fields here, just for information, the focal length of the lens, which is calculated from a so-called paraxial approximation. And when you add this ray fan option, then you will also get a root mean square spot size, so a measure of how well the light is focused here at the final image plane. The smaller the number, the better the focus. The settings that you now can choose from are the radius, so the outer diameter of the lens, then the radius of curvature of all the lenses, which by default are spherical shape. Negative curvature or negative radius means lens is curved to the right. Positive, it's curved to the left. Let's leave it at negative here for this example. And then you have this option for surfaces 2, 3, and 4. Be mindful, as you can see here, not all aspects of the geometry are currently checked whether they make sense and automatically limited. So in this example, surfaces 2 and 3 would overlap. That is not automatically filtered here. And then finally, there is center thickness of the segments, which means the distance between the individual surfaces. Finally, there's index of refraction for the 3 glass segments. And this is only used for the internal ray tracing feature. So this is not automatically converted to, for example, Cycles material settings. That is what I will explain in the 3rd tutorial video in more detail. Yeah, so those are the most important settings that I have selected. Then in optical design, there are a few more settings. So as I said, by default, the surface shapes are spherical. And now here you have aspheric coefficients. So one is a so-called conic constant. For example, -1 will turn the surface into a parabola, which in this example is not very obvious, but you can see that there is a change. And then these parameters called A, these are polynomial coefficients for 4th, 6th, and 8th power. So depending how large your lens is, these may need to be very small. So you can see, for example, 10 to the -8 for the, 8th order, 8th power coefficient will have an impact like this. And also the last change in this detailed optical design page is that you can create a flange, so a flat rim around the surfaces, which in reality you will find mostly for concave surfaces like this one. So those are the optical design settings. Then in ray tracing, we can influence a bit this ray tracing that is done. So for example, the number of rays can be increased or decreased. The detector distance, which is the default distance where the image is ray traced to, can be changed. Also the origin, which in this case for this fan, all the incoming rays are parallel, so this doesn't really change anything. But we can change the distribution of the rays. So this 2D with all incoming rays parallel can be changed to 2D finite, where now the origin is a position of the finite object or finite point source that the rays are generated from. We also have option to change the angle and narrow down the beam, so to simulate stopping down the lens. So let's go back to default settings. And besides these 2D options, which only generate rays in the cross-section plane, there are also 3D options, for example, rings. Now for the 3D distribution, we typically need a few more rays. So here we would have an initial distribution in rings, but there is also square distribution, triangle distribution, and a completely random distribution, which each time you regenerate this will change the rays. There's also an option, trace ray fan to scene, which I cannot demonstrate here because there's no other geometry in this setup. But if I delete everything and create a Suzanne, where's Suzanne? There. Let's place Suzanne somewhere over here. And now we generate the lens again. Then with the trace fans to scene option, we can see that only the rays that hit Suzanne will be rendered after the final lens surface. Okay, let's go back to a more reasonable 2D ray setup. So these are the options for the ray tracing in the ray tracing menu. Then finally, there are some settings in the model geometry page. So there you can get some have some options for translation of the model or rotation. So Blender's default settings, and also the parameters for how high the resolution of sampling of the generated model is. There are also 4 material slots here that you can see. So if you have some like cycles materials predefined, you can assign them here and get a faster rendering preview. However, as I said, these materials are not automatically generated, and so this will be covered in the 3rd tutorial video. There is now a last page, which is for labeled paraxial optics. However, at the moment, this only holds a copy of these refractive indices that were also on the most important page, and this whole page is rather reserved for future updates at the moment. So yeah, those are the settings available for the lens. Let's delete everything and move on to the next object, which is the square lens, which is so far unchanged from the from before the recent update. So instead of a round lens, this creates a sphere lens. Here you only have the option of the singlet lens, so 2 surfaces, and also reduced feature set in general. In next stage, I will transfer all the ray tracing options, etc., that I've now added to the round lens. I will apply those also to the square lens, but it is not yet available. So here you can choose explicitly whether you want a spherical or aspheric surface with the same kinds of coefficient as for the round lens. And the most important feature of the square lens that the normal lens doesn't feature is the option to have a cylindrical lens. So using the radius here, you can see that in the top view you can have a spherical cross section, but from the side it's flat. So this would, for example, be useful if you are trying to make anamorphic lenses. So that's the square lens. Then there's also pretty much unchanged from before the update, the mirror, which by default you see here is rendered with a parabolic surface because parabolic mirrors are quite common in optics, and origin is not at the center of the surface, which you can also choose, but at the focal point. This is because it's very common in laboratory to have off-axis parabolic mirrors which deflect the ray by 45 or even 90 degrees, and that's why this option is explicitly offered here to allow to generate such mirrors. But you can also choose a spheric surface because a parabola is only a subset of a spheric surface, or spherical surface also a subset of a spheric surface. But there are spherical and parabolic explicitly at the moment, because one further option that besides this off-axis angle that they offer is to have a central hole. So you can have a hole at the center of the mirror, which you would need, for example, for telescopes. So at the moment, the aspheric surface does not yet feature this. You see that if I try to generate a sphere with a central hole, I get some error. This will have to be added in the future. So next up, there is also a retroreflector array. So this is an array of cube corner segments which optically will reflect any incoming ray in the direction that it came from, so turn it around by 180 degrees. So this could be used to model like reflectors in cars, so safety reflectors. However, these reflectors, because they are not designed to reflect light perfectly back, otherwise from the headlight of your car the light would be reflected back into the headlight and not into the eyes of the driver to make it more visible. So instead they are modeled with some slight deformation, which is available here through offset of the tips. However, I cannot give actual guidance of how exactly these offsets would have to be chosen for you to create the real effect from a real reflector, but at least this feature is offered here. And then there's also a Siemens star feature, which is a common target for testing the resolution of lenses. You have a number of spokes like this, which you can choose. Of course, you can change the size. Also, the 3D thickness of the model can be changed. It can be generated either open-ended or closed-ended. And you can set the resolution of the outer rim. So this can be used to test lenses that you design with this add-on. And finally, the real big update, I would say, that I've now included in this add-on is loading lens design from a zmx file. So zmx is a professional optical design software, and a lot of lens designs from patent literature, for example, are available on the internet in their zmx format. So I have here pre-selected some models that are available online, for example, a wide angle lens, and you can see that it automatically imports, what is it in this case, 13 different lenses. Again, you can generate this as a cross-section model, view it in addon mode, and add the sequential ray tracing, for which for this lens we need a lot more rays, and this will take all the lenses into account. You can see that the focus spot generated here is quite good, so this model was imported correctly, and we can see how the lens works. Similarly, there are options to trace the ray frame to a scene if you have objects already. This automatic focus improvement is available. We can reduce the stop of the lens, which is also imported from the zmx file and generated here as a disk. You can see how that is changed. Of course, we can change the ray angle, and for better visualization, because you see that not all rays that are initially generated make it through the stop of the lens. So you can only display those rays that are uninterrupted, and this really helps you to better visualize how the rays behave in, for example, this time of wide angle lens, where you can see that from at the first lens, which is very big, only a few rays actually contribute to the image. So yeah, this import from zmx file is what will be covered in a lot more detail in the next two tutorial videos, where I will show a lot more examples that you can find online, different types of lenses, mobile phone lenses, wide angle, fisheye, or also simpler lenses, and we will explore them in a bit more detail. So that's it from the optics menu, and then, as I said, unchanged from the previous version of this add-on, there is the option to create an optical breadboard, by default rather large. So let me change the view settings. So this is a tabletop with a lot of 6mm holes, because they normally have a M6 thread, these optical tables. And of course the thread is not modeled, because that would create way too many vertices. You can instead, if you want to, generate them by shader. And to simplify setup of that, by default, if you go into edit mode, all the faces inside the holes are pre-selected, so you can easily apply a predefined material to these faces in particular. And the last Optomechanics feature that is available is a Torlap style optical post. So strictly speaking, you don't really need to generate this from this add-on. You can also download a CAD model from manufacturer website and import that, maybe converting it with some other CAD software to an STL model. Yeah, but this one I implemented some time ago as a dynamic model that you can change arbitrarily in height, but other than that you cannot affect its shape because it's a fixed design. Okay, so this was the brief overview of the OptiCore features, and yeah, watch out for tutorial videos number 2 and 3, where I will go into more details about the individual optical design parameters, what you can do with them, go through a lot of models from patent literature and what you can find online, how you can import those, what you might be able to do with those, explore a bit the optical design principles, and then also in the third video show you how to set up one of these more complex lens systems with cycles materials and generate an image rendered through to some of these lenses. Alright, thanks for watching and see you in the next video.